Hi. This was a great kinematics question that I had, and I thought it would be really good because this is a very non-traditional style of two-dimensional kinematics, and that's why the process is so important. So, this is just another example of the kinds of, solutions or explanations that I'll give to students. Students of mine, they can ask me these kinds of questions anytime, and I'll always provide a response, usually pretty rapidly, actually. As ice skates, two ice skaters pass right by each other while doing a routine. So they're going to pass right by each other when they're directional jetpacks. At this moment, the skater in the red suit, so let's put a red dot for the red suit skater, is traveling a speed 5 meters per second in the direction 30 degrees from the positive x-axis. So going this way, 5 meters per second at a direction of 30 degrees from the positive x-axis towards the negative y-axis. Oops. So it's actually below. So what that means is it's going this way at 5 meters per second, 30 degrees, like that. And the skater in the blue suit is traveling 4 meters per second, so right next to him, they're passing by each other, is going 4 meters per second in the positive y direction, so 4 meters per second upwards this way. As they pass each other, their jetpacks turn on, shooting flames for effect, providing each of them a constant acceleration. The acceleration of the skater in the blue suit is in the positive x direction. Has a magnitude of 4 meters per second squared. Okay? While the acceleration of the skater in the red suit is the positive y direction, so this guy's acceleration is upward at, we don't know what it is. Okay? With their jetpacks turned on the entire time, they eventually meet again and pass right by each other. How much time elapses between the two times side by side? So this already, the scenario is a very non-traditional projectile motion type question because you really have to understand what the shape of the motion is going to be. So this one is almost like a projectile motion, but the path is going to be like this. Okay? And this guy is going to have a path that looks kind of like this. And at some point, they're going to meet here. They're going to pass by each other. That's what they're telling us. We don't know the acceleration, but somehow they're going to meet it there. Okay? So how much time elapses? So let's talk about breaking this up. Let's talk about for the blue guy and for the red guy. Right? The blue suit. Now, we have to split it up into x and y components, right? So this is our process. This is the same process you do no matter the kind of kinematic question it is. We do it every single time. You might be like, well, we haven't practiced this kind of question. You might not have practiced this kind of question. This is not a question I've seen before. But we still set it up the exact same way. So let's think about, we got to set positive directions. Well, they already told us positive x and positive y. Kind of like the normal xy axis system. Okay, so let's look at this one. Horizontal displacement. I have no idea what that is. Do I know the vertical displacement? No idea what that is. How about the initial velocity? Well, the initial velocity is upwards at 4 meters per second. That means it's 0 in the x direction because it's only pointing up. There's no x or y component. Sorry, there's no x component. It's not going to the right or the left at all. But the v0 is positive 4. It's upward at 4, upwards the positive direction, so we say positive 4. Final velocity, we have no idea. We know the acceleration is in the x direction at 4 meters per second. But because the acceleration is only to the right, there's no up or down acceleration. This is 0. And then we want to know the time or anything like that. So what we'll probably do is, I don't know. Let's just list out. So those are the things that we know. Obviously, it's not a lot to solve for. But let's take a look at the red side of things. X and Y, we're going to do the exact same thing. This is something that if you just jump right into equations, it's not going to make any sense. It's not going to work. You're just going to be like, I don't know what to do. And I know what you should do. You should always start by drawing a picture, and then you should list out the things that you know and you don't know. Okay, for the red guy, okay, so let's look at displacement. Again, I don't know the displacement, but it's the same as the blue guy. Notice that they both should have the same displacement because they're both going to end up at the same spot. So it should be the same. So maybe we should call this, let's call this distance from here to here. We'll call this x, f, I don't know, final distance. And then we'll make it, this side to be yx, yf. Something like that. So I'm going to make this xf and yf, because we, at least, even though I don't know what it is, and they didn't give me a variable, I know it should be the same because they're going to meet here at the same time. Okay? And then this is yf. So we're just up and then to the right. Initial velocity. Well, this guy has an angled velocity, so what are we supposed to do is we have to decompose it into x and y, right? So this is 5 cosine 30 degrees. This is 5 sine 30 degrees. Okay, that's the next step we do. So 5 cosine 30 is to the right, so that's in the x direction, so that's 5 cosine 30 degrees. And remember, cosine's always the adjacent side there. And then this is downward, so this would be negative 5 sine 30 degrees. Why negative? Because I said up was positive, so this arrow points down. Down is the negative direction. Okay, now final velocity, I have no idea. The acceleration, I know it's upward, so it's 0. And then we'll just give this a term. We'll call it A. We'll just call it A for this one. But I expect it to be negative. Why negative? And I might as well just put a negative sign there. Negative A. Why do I expect it to be negative? Because it is pointing upwards. Okay? It's pointing in the upward direction, which means that... I don't know why I said negative. It should be positive. I don't know what I'm thinking. It's pointing upward. I was thinking about the velocity. The acceleration is pointing upward. Upward is the positive direction. Okay? So we just call it A. Like, I don't know what that is. Okay, and then they should have the same time, t. Okay, so we'll put just letter t for time to indicate that it will be the same for all 4 of these, because they have to meet there. It can't be like the red guy gets there first and then the blue guy passes there. It says they meet again, so at the same time, they are passing by each other. So it's the same time from here to here. So that's our setup, all right? So now let's look at like kind of everything. If we look at it, we have 4 unknowns: xf, yf, time, and acceleration. Everything else we know, so we are just going to come up with equations that relate these quantities here. The quantities that we know in the problem, which is going to tell us to use this equation. And we only use this equation simply because those are the 4 variables we are attempting to relate here. So for this column, it's going to be xf is equal to 0. This is going to be 1/2 times 4. That's going to be 2t squared. This is going to be yf is 4t. Then this is going to be xf is 5 cosine 30 degrees times t. Right? We're just using this equation. I'm just plugging in. There times t, 1/2. That's just 0. So just 0 that thing out. And then for this side of the equation, I'm going to do yf is the displacement. It equals this one, negative 5 sine 30 degrees times t plus 1/2 at squared. Okay, so these are my 4 equations. 4 equations and 4 unknowns. Okay, because the displacements are the same, might as well just set those two equal to each other. And then you can divide the t. T is not 0, so you're allowed to divide by t. Remember, mathematically, you'd be careful. I can only divide by t because I know it's not 0. Why do I know it's not 0? Because it took some time to get from there to there. It can't be 0, so I can divide out the t. So the t is going to be 5 cosine 30 degrees divided by 2. Like, the rest of this problem is now a math problem. We are done with the physics part. The rest is simply math at this point. 2.2 seconds. It says 2.17, whatever. What is the magnitude of the acceleration of the red skater to achieve this feat? So the red skater, this guy, let's connect these. Well, we can say this is equal to that. Why am I doing that? Because this is the one that has the A in it, right? And I know the time. Well, first of all, I can divide the time. It's not 0. And I can plug the time right into there. So then I can solve for it. 4 equals... Negative 5 sine 30 is negative 2.5 plus 1/2 a times this. It's actually 2 point. Don't use the rounded value, by the way. You should always use the unrounded value. And then we're just going to solve for a. We're going to take the 4, add 2.5 times 2. Oops. Take the 4, add 2.5 times 2, and then divide it by this time value, which I'm just going to scroll up under the calculator to pick, and I get this about 6 meters per second squared. Okay, cool. What is the change in position during this time? Awesome. Well, we can find xf. That's the x change in position. See, now it all just comes together. The setup was the hardest part, literally. That, and then I have to square it. So that is 9.37 meters in the positive x direction. And then the YF is 4t, which is 4 times 2.165, which is going to be 8.66 meters in the positive y direction. Why positive y? Because I got a positive number, so it would have. What is the final velocity for each skater? Let's solve. We have to solve for v here. Now we have a lot of this information. We're literally so this is all of this time we now know is 2.165, 2.165, 2.165, 2.165, right? And we just got to find the final velocity. We're always going to use v equals v0 plus at. That's pretty much all we're going to use for all of these because we have the time and we know v0 and we're just trying to find v. That's the easiest way, the fastest way, probably to find it now that we know the time. So that's 0 plus 4. So for this one here, 4 times 2.165. Let's call that 8.66. This one, because the acceleration is 0, v is going to equal v0, so that's 4. Here the acceleration is 0, so v is going to equal to v0. What's 5 cosine 30 is 4.33. And then again, this one, you're going to do v0 plus a times t. But now we know what the a is. The a is 6. So you're going to do negative 5 sine 30 plus 6 times 2.165. And that gives me, I don't know, negative 0.2 meters per second. Okay, so that's the final velocities there. This is the x, this is the y, this is the x, and this is the y. If you want the speed, you'll use Pythagorean theorem to put them together because this is the x and the y component separately, and then you can put them together. And that's it. So it's not any different. Like, it's tricky. I would say the hardest part is the diagram, but the process is always the same when we're handling those kinds of kinematics or 2D kinematic problems.